Yeah, my name is Georg. I work on V8. V8, you probably know, it's the JavaScript engine that's used in Chrome and also in Node.js. But this talk is not really about Chrome or V8. This talk is about ECMAScript modules. ECMAScript is the name of the official JavaScript language specification, and modules are a feature that were added already a couple years ago to the language, but only recently, like last year, made it into most browsers and other tools. So in this talk, I want to give you two. I will talk about the past, like the history a little bit, about the present, what we have right now, what it looks like, how it behaves, and things that we can expect in the future. So in the old days, if you have been around in the old days, you may know that the way people programmed using modules was basically just putting everything into the global scope. So if you wanted to use something like jQuery, you had to make sure that you put the script tag into your document in the right position that includes the jQuery file. And having these implicit dependencies is a very fragile mechanism, and you may get the order wrong of the way in which you include the files, right? Or you may get name clashes because everything is in the global scope, and so there's this complete lack of encapsulation. Some early attempts to improve this situation was on the one side programming patterns that people proposed, like you may have heard of the revealing module pattern. But also on the language side, on ECMAScript, there was a feature called packages at some point, some kind of a namespace. That was abandoned again, so it never actually made it into an official version of the specification. Some people from the ECMAScript committee and some other people then proposed a format called CommonJS. It's a definition of a module format, and you probably all know this because a version of this is what's used today in Node.js and NPM. And this was really designed for non-browser systems. So we see an example here. You have a main module where you import another module, a circle module, and this require function is what CommonJS gives you, and it really is a synchronous operation, right? And then you get back an object representing this module. But nevertheless, people actually use this for web development, and then they use bundling tools like Webpack to eliminate the requires again. There's, however, also an asynchronous module format called AMD, and that's used by other tools such as require.js and curl.js and some other loaders. Here you also have a require function in the corner over there, and you tell it what you want to import. But this time you also pass it the code that consumes that module that you're importing, right? So it's a callback that you pass, which does all the work using the circle module. Then there's something you may have heard of called Universal Module Definition, UMD. This sounds very profound, but it's just really a clever way of writing your code such that it is compatible both with the CommonJS world and the AMD world. So you can see there's some conditional here that checks what environment you are in, and then depending on which one it is, you do different things. So these maybe are the most common approaches that people know, but those are all external to the language, right? There have been plans to integrate modules into the JavaScript language itself for quite a while. And originally, TC39, that's the committee in ECMAScript working on the language, they intended to fully specify module system for JavaScript for ES 2015 or ES 6, a different name. That did not quite work out. There were several complications and delays, and in the end, people decided to exclude everything related to loading modules from the specification. So what was left in then was the syntax and semantics of import and export statements. That's still more or less the way it is now. So there was a separate loader specification being developed then, but again, there were some issues there, and It didn't progress as hoped, and so eventually people decided to move the uncontroversial parts of that specification into the HTML standard. Yeah, that's basically where we are now, a modular bunch of revisions since then on both sides. The loader specification still exists. You can look it up. It has a website. But if you read the text on that side, I don't know, it doesn't look like there's anything happening there at the moment. And as far as I know, browsers don't implement any of the things being proposed in there. Okay, yeah, so that's the specification side. Browsers implemented this mostly over the last year, and it's available now in all major browsers. I think in Firefox, just a few weeks ago, it was turned on by default. Okay, now I would like to tell you what it actually means to have module support in the browsers. So on the HTML side, there is a new script type module, which you can use inline or with a file. And this tells the browser to please execute this code with the module semantics and syntax. So the syntax and semantics of module scripts is slightly different from that of classic scripts. For developers, there's a migration path that uses a new attribute called no-module. So you can provide a fallback implementation. And then the idea is that browsers who support modules, they will recognize the module type over there, and then they will run the module code. And they will recognize the no-modules attribute and will skip this script. And browsers who don't know modules, they will skip this one because they don't recognize the type, but they will execute this one because they simply ignore the unknown no-module attribute. And this is actually very powerful because browsers who support modules are also browsers who support other ES6 features, right? So you can, for instance, if you want to use modules, you can provide a bundle as you usually do for old browsers, and a different bundle for new browsers using the module tag. And then in that code, you don't need to transpile to ES5 because arrow functions and so on will already be available in that. Then there's also a complex specification in HTML of how these scripts are actually processed. So it's about how things are fetched and loaded asynchronously, and how errors are being reported. But I don't want to say more about HTML at this point. Let's look at the ECMAScript side. The main difference between module scripts and classic scripts is that in module scripts you have additional syntax, namely import and export statements. There are a few other differences. One is that all module code is strict code, and there's no way to change that. Also, all module code is in a lexical top-level scope. That means when you have top-level declarations, they will never end up on the global object. Another difference is HTML-style comments are not allowed in module code. So you can no longer write something like this. And probably you didn't even know that you could write that before. Another difference, module code is only evaluated once. So even if you have several script tags that load the same module file, the module will get run only once. Okay, let's look at imports and exports in detail now. First of all, they are top level only, so they really are static. That means that before any module code runs, it's already clear what gets imported and exported. I think that's very different from some of the other module systems you may be familiar with. The basic forms for imports look like this. So we want to import something from module foo.js. This is the module specifier, and it has to be a literal. It cannot be computed at runtime. And you're importing something that's called A in module foo, and you're calling it B in your own local module. So this introduces a new name B into the local scope. There's a short form for the case, for the situation where you don't want to rename the thing. And there's a third version where you don't actually import any particular component, but you are just depending on the other module for the sake of its side effect. But I think this, in general, it's a good idea to avoid this, and I will say a little more later. On the export side, there's an export ASB statement, which exports a local variable A under the name B, such that other modules can import it by referring to it as B. And again, there's a short form. You can also put export in front of any declarations, and it has the obvious meaning. Okay, now you have seen the syntax of imports and exports, and you have a vague idea of what it means, but let's look at an actual example to understand the semantics. So we have two modules here, a main module, which imports X and Inc from a count module. So the idea is count. The count module provides a counter. It exports a variable X and an increment function. And here we are in the main module, we are logging X first. So this will print 0. We are calling the increment function. So this next time it will print 1. This shows you that X is actually not a constant, right? It's being mutated when you call inc. And so the second time we call this, the value has changed. And then we change it manually, but this time we will get a type error. This, in a sense, shows you that these bindings are also immutable, meaning you cannot directly mutate them. It has to be through functions being exported by the module that owns the variable. Okay, there are a few other forms of imports and exports. One of them is indirect exports. Let's look at this example. This is already this is written in the syntax you already know. So we are importing an A from Foo.js, and we are again exporting it. So it's a re-export of something from another module. And there's shorthand for this that looks like this. So we just say export A from Foo.js. The only difference between those two is that in the first line, we are actually introducing A as a variable in the local scope. In the second form, we are not. All right. So then there's something called star exports. Star exports is when you export your favorite functions. Oh, this was a joke. So star exports means you're exporting everything from another module. Here's an example. We have a module bar.js that exports X and A. And in main, we can say export star from bar.js, so export everything from bar.js. And in this example, this is equivalent to exporting X and A. Right. So just looking at the module that does the star export, you don't know what gets exported, but when you look at the other source code, you will know. Yeah, so that's the next slide. There's something called star imports. It's a counterpart, but there's an important difference as well. Same example from before, the first module. So in the second module now we import everything. So we say import star, but we have to say as bar. So here we have to give a name to not, here we're giving a name to a so-called namespace object. So this does not introduce, this does not immediately import all the things and puts them into your local namespace, but it imports everything in the form of an object that you call bar. So you can choose the name for the object, and then you can access the exports using just property access. Right. Okay, so much about imports and exports. Let's look at the life of a module. The life of a module is a very simple life. It starts out uninstantiated. This is right after parsing, basically. And once all the modules are available, all modules that are part of the dependency graph, you can instantiate the whole graph. Then every module becomes instantiated, assuming assuming instantiation is successful. In the error case, they will remain uninstantiated. So we will see examples of when instantiation can fail. So once the whole graph is instantiated, you can evaluate it. And I will tell you more about these two operations. Evaluation, so first of all, it requires that instantiation has succeeded. And then it executes the code of each module, but in a certain deterministic order. You can think of it as dependencies first. It's a depth-first search, post-order traversal. This dependencies first does not quite make sense when you have cycles, because then it's not clear really what is the dependency. So it can happen. You can happen in a situation where you run your module code gets executed, but the modules from which you import have not yet been evaluated. In the presence of cycles, that can happen. There's another thing worth knowing, which is that even when you know that that the module you imported from got executed, you can't really be sure that it got executed right now, just prior to you, because it could have already been in the browser's module map for quite a while. So in terms of the counter example from before, so we have this counter, we are importing X and we're printing X. If this is the only code that you control, then you really have no way, you have no idea what value X has at this point. Because it could happen that counter module was already executed like long time ago and used by other modules. So for instance, you could have, HTML could have these two script module scripts. Foo is the one we have here, bar is something we don't know. It might be using count as well, and it might have incremented many times. So by the time your module runs, you don't know what the value is anymore. So you have to be a bit careful. So in general, it may not be a good idea to have side effects at the top level. Okay, instantiation. I wanted to give you some examples of failures. This is the simplest I can imagine. You're importing something from an empty file. Clearly, this doesn't work. And this will give you a syntax error, which will be reported to either the script error handler or the window error handler, I'm not sure. Another example is a cycle. So we have foo1 and foo2. Foo1 takes x2 from foo2 and right, and what is x2 from foo2? X2 from foo2 is x1 from foo1, so you see that doesn't really make sense. So this will be rejected as well at instantiation time. A simpler version of the same problem is this one here, where you just have a single module that re-exports x from itself. So where does x come from? Well, from itself, and where does it come from, and so on and so on. So that doesn't mean that you can never have cycles. That makes sense. So there are valid cycles. A simple one, which also is not very useful, is this one. This is just a no-op. More interesting example is this. So by the way, these cycles, they can sometimes arise in actual software. Yeah. I'm not just demonstrating this as something obscure. So can you, yeah. So here we have a module foo, a module bar, and a module main. Foo, let's start with foo. Well, so first of all, this instantiates successfully, okay, although there's the cycle. And let's see what happens at evaluation. So when we evaluate main, the first thing we do is we evaluate bar. And when we evaluate bar, the first thing we do is we evaluate foo. When we evaluate foo, the first thing we do is evaluate bar again, but bar is already being in the process of being evaluated, so we will skip it at that time. And then we will run this code, so we will log 1, we will define function f, and eventually we will end up back here. We will print the result of applying f, and then we are done. So this will print 1, and then it will print 42. So now we are making a small change to the example, which is we are starting with the other one first. Okay? So you see how the graph has changed. So now we're evaluating main, so we evaluate foo. Foo, we evaluate bar before we do anything else. And in bar, we evaluate foo, but we're already doing that, so we skip it. Now we will print the result of f. But at that time, f has not yet been initialized. So we will actually get a type error now, because undefined. So f will have the value undefined at this point. It's a var declaration, and var declarations, uninitialized var declarations always have the value undefined. Yeah, that's right. Imports are hoisted to the top. So we'll get a type error here. Now I'm making another change now. The definition of f, I'm changing it to a const declaration. Any guesses what will happen now? So what will happen now is we will get a reference error. So the evaluation proceeds the same way as before. So at this point, f is uninitialized. Uninitialized let and const variables, well, you're not allowed to access them. You will get a reference error. That's what we sometimes call a temporal dead zone. So this is, even in normal JavaScript, you have this phenomenon. Here in modules, it may appear a little more surprising, but it's actually consistent with the existing semantics. Final change, now we're having a function declaration. And what will happen now? Well, what will happen now at the point when we call f, f is actually initialized to the function value we see above. So we will first print 42, and then we will first print 1, and then print 42. Did I get it wrong? Yeah, I got it wrong. This should be first 42, then 1. And yeah, the reason is that functions are hoisted to the top, as you know as well from classic JavaScript. Here you can think of them as being hoisted out of the whole module graph. So before any module code runs, all function declarations are already available. Okay, let's stop with the crazy examples. A few words about deployment and loading. So obviously on the web it's expensive to fetch many files. So if your application is really large, this may be a problem. Some things you can do are telling the browser to prefetch things, so to fetch resources in advance. The one mechanism is something new that is, I think, available in Chrome only so far. This is module preload mechanism, similar to the preload mechanism that you may already know. So initially they wanted to just extend the existing preload mechanism, but due to some fundamental differences between module scripts and classic scripts, they ended up having introducing a separate module preload. Then, of course, you can also use HTTP2 to push dependencies early on. But you can also, and I think that's a reasonable thing to do, just keep on bundling. There are several bundlers support ECMAScript modules, and this not only results in fewer files and shorter code, and you can deploy different bundles for different versions of browsers, as we have seen in the beginning, but also specifically for ECMAScript modules, they can do some actual optimizations. Because the imports and exports are static, you know in advance what things are required, what things are actually being used, and so the bundlers can just drop all the other things that you're not importing. And so you eventually end up saving a lot of code this way. On the Node and NPM side of things, it's a little bit unclear what's going on there. So first of all, there is experimental support in Node 8 behind the flag. They require that module files end in the file extension MJS, because they need some way of you telling Node whether this is a classic script or a module, right? And this is how they chose to do that. And if this turns out to be be established, then this may be a good thing to use even on the web. It allows bare module specifiers. That means you can do something like import Lodash from Lodash. So you can say Lodash without saying what particular file it is, where to find the file. Just as with require. It allows importing common JS modules. It does not allow requiring ECMAScript modules. And like I said, it's experimental, and there are several issues that are not sorted out yet, from what I understand. One goal they also seem to have is interoperabilities, and one thing that complicates this is the fact that some bundlers, they simply translate import to require, kind of ignoring the fact that import is associated with a slightly different semantics because everything is in script mode, for instance. There's actually a whole team of people working on finding a good solution there, and I think they have a meeting right now or this week in Berlin, but I don't know of any outcomes of this yet. Also, towards this interoperability issue, there is a proposal called package name apps, where the idea is that in order to support this, in order to make the code that you run on servers as well, basically the same code that you also run on the web, you would like to have some way of telling the browser what bare import specifiers mean. So if you write something like this, you want a way to tell the browser what does this refer to here, this Lodash or this moment. And using these package name apps, you can then provide some separate file that tooling can generate for you, where you provide a mapping of these specifiers to actual path names or URLs. All right. WebAssembly also has a notion of modules. They are trying to incorporate it with ECMAScript, and there's one issue there is if they want to allow cycles at all, and going further, if they want to allow cycles that involve ECMAScript modules. And doing so would require some changes on the ECMAScript specification, and I think there's a proposal for that at the moment. And I want to finish with a few, by mentioning a few proposals for ECMAScript. First of all, there's the import meta object. That's already implemented, at least in Chrome. I don't know about other browsers. So here, it's a new syntax for accessing some kind of meta information. So import.meta is an object that has a bunch of properties that tell you information about the script you're executing. And I think it's kind of like a replacement for document current script, which for modules is no longer clear what it actually means because you have a whole graph, right? Then very important, dynamic imports. So I only talked about static imports so far. Dynamic imports let you import things conditionally, like dynamically at runtime. And the specifier as here can be an arbitrary expression, a computed string as well. So here the idea is that because it's dynamic, what you get back is a promise. And that promise gets resolved with the namespace object. Remember the import star? That's the namespace object. And this is something you can also use in classic scripts. So from classic scripts, you now have the possibility to trigger a module execution. And finally, related to this, there's a proposal for top-level await. So when you have these import expressions that return a promise, you end up in writing in this asynchronous style, and people have the desire of just writing something like this here, await import at the top level or within a conditional at the top level. Right. I think that's all I have. Thank you very much. I'd be happy to discuss when people have questions. I will be in the corner over there. I am not in Twitter myself, but we have this V8 Twitter thing, channel. I don't know what it's called. There we post talks there and links to blog posts that explain internals of V8, and you may find it useful. Thank you.